Ever picked up a simple bar of soap and thought about what went into making it? It looks basic, but inside a factory, soap is the result of controlled chemistry, industrial engineering, and carefully balanced ingredients working together at scale. From raw oils to fragrant finished bars, the journey of soap is far more detailed than most people imagine. Let's go step by step through how soap is made in a modern factory, from raw materials to the final packaged product. Raw materials and ingredient preparation. Soap production begins with a carefully selected group of raw materials: oils or fats, an alkali, water, and optional additives such as fragrances, colorants, exfoliants, and skin conditioning agents. Each ingredient plays a specific role in determining the final properties of the soap, including hardness, lather quality, scent, and moisturizing ability. The oils used in soap making can come from both plant and animal sources. Common plant-based oils include coconut oil, palm kernel oil, and olive oil. Coconut oil creates a strong cleansing and rich lather, while olive oil produces a gentler, moisturizing soap. Animal fats like tallow are sometimes used in industrial soap production because they create a harder, longer-lasting bar. The alkali is usually sodium hydroxide for solid soap or potassium hydroxide for liquid soap. This chemical is essential because it drives the reaction that transforms oils into soap. It is highly reactive and must be handled with strict safety procedures in controlled environments. Before production begins, all ingredients are measured with extreme precision. Industrial soap manufacturing relies heavily on accuracy because even small variations in ratios can change the texture, performance, or safety of the final product. Automated weighing systems are commonly used to ensure consistency across large batches. Water used in production is purified and filtered to remove minerals and impurities. This ensures it does not interfere with the chemical reaction or affect product stability. In large factories, entire water treatment systems are dedicated to maintaining this level of purity. Saponification, the core chemical reaction. At the heart of soap production is a chemical process called saponification. This is the reaction where fats or oils combine with an alkali to form soap and glycerin. Inside large stainless steel mixing tanks, oils are first heated to a controlled temperature so they become fully liquid and easier to process. Once the oils reach the correct consistency, a carefully prepared solution of sodium hydroxide and water is slowly added. This stage is highly controlled because the reaction produces heat. If the temperature rises too quickly, it can affect the texture and stability of the soap. Industrial mixers continuously stir the mixture to ensure even distribution and prevent separation. During saponification, triglycerides in the oils break down into fatty acid salts and glycerin. The resulting soap molecules have a unique structure. One end is attracted to water and the other is attracted to oil and dirt. This dual nature is what allows soap to clean effectively by lifting grease and impurities from surfaces. Glycerin, a valuable byproduct, is often separated during production. Many modern manufacturers refine and reuse glycerin in skincare products because it has strong moisturizing properties. As the reaction continues, the mixture gradually thickens and transforms into a soap base. At this stage, it may resemble a gel or paste depending on the formulation used. Mixing, additives, and refining. Once saponification is complete, the soap base moves into the blending stage. This is where the product begins to take its final identity in terms of scent, color, and performance. Fragrances are added to give the soap its signature smell. These can range from floral and fruity to herbal, woody, or medicinal. Colorants are also introduced to create visually appealing products that attract consumers and differentiate product lines. Additional ingredients such as aloe vera, shea butter, glycerin, vitamin E, or natural exfoliants like oatmeal may be added. These enhance the skincare benefits of the soap, making it more than just a cleansing product. The mixture is then blended using large industrial machines called crutchers. These machines mix the soap thoroughly to ensure that all ingredients are evenly distributed. Temperature is still carefully controlled because heat can affect fragrance stability and overall texture. After blending, the soap mass undergoes refining. This step smooths the texture, removes inconsistencies, and ensures the product feels uniform when used. The goal is to eliminate lumps, air pockets, or uneven distribution of additives, drying, and soap noodle formation. In large-scale manufacturing, the soap mixture is often dried to reduce moisture content and improve stability. This is done using vacuum drying systems or spray drying techniques. Vacuum drying removes water at low pressure, preserving the quality of the soap while increasing concentration. Spray drying involves breaking liquid soap into fine droplets that dry instantly in hot air. The result is often soap noodles or flakes, which are semi-processed soap bases. These noodles are highly stable and easy to store, transport, and further process. Soap noodles serve as the foundation for many commercial soap products. They allow manufacturers to create different variations simply by adjusting additives in later stages. Milling and texture refinement. Soap noodles are then passed through a milling process to improve texture and consistency. Heavy rollers compress and refine the soap repeatedly, folding and smoothing it into a uniform mass. This process ensures that all ingredients are fully integrated and that the soap has a consistent feel throughout. It also improves lather quality and overall performance during use. Milling is repeated several times, depending on the desired quality level. Premium soaps often undergo more intensive milling to achieve a smoother and more luxurious texture, extrusion, shaping, and cutting. After milling, the soap is ready for shaping. It is fed into an extruder, which compresses it into a long, continuous bar of uniform density. This extruded soap is then cut into individual pieces using automated cutting machines. Each bar is precisely measured to ensure consistent size and weight across the entire production batch. Some factories use molds instead of extrusion. In these systems, soap is pressed into shaped cavities that define its final design, including curves, logos, or decorative patterns. Stamping and branding. Once shaped, soap bars are stamped with brand logos or decorative impressions. Metal dies press into the soap surface to create recognizable branding and visual identity. Stamping not only adds aesthetic value, but also helps distinguish products in the market. Some soaps feature textured patterns or embossed designs that improve grip and enhance appearance. Drying, curing, and hardening. Freshly formed soap still contains moisture and must go through a curing process. During curing, soap bars are placed in controlled drying rooms with regulated airflow and temperature. Over time, excess water evaporates, making the soap harder, longer lasting, and more stable. Curing also improves mildness by allowing the chemical structure to fully stabilize. Depending on the formulation, curing can take several days or even weeks. Proper curing is essential for producing high-quality soap that performs well during use. Quality control and testing. Before soap is approved for sale, it undergoes strict quality control testing. Manufacturers test pH levels, hardness, moisture content, fragrance strength, and lather performance. Microbiological testing ensures that the soap is free from harmful bacteria or contamination. Stability tests simulate different environmental conditions to ensure the product remains safe and effective over time. Any batch that fails quality standards is reprocessed or discarded to maintain consistency and safety. Packaging and distribution. Once approved, soap bars move to the packaging stage. Packaging protects the product, preserves fragrance, and provides branding and usage information. Automated packaging lines wrap, label, and box thousands of soap bars per hour. Labels include ingredient lists, manufacturing details, safety instructions, and expiration dates. Finally, the packaged soap is shipped to warehouses, retailers, and stores around the world. Efficient logistics ensure that products reach consumers quickly and in excellent condition. The journey of soap from raw oils and chemicals to a finished bar is a remarkable combination of chemistry, engineering, and precision manufacturing. Every stage, from saponification to curing, is carefully controlled to ensure quality, safety, and performance. What seems like a simple, everyday item is actually the result of complex scientific processes and large-scale industrial coordination. Each bar of soap represents careful formulation, controlled reactions, and detailed quality checks. So the next time you wash your hands, remember the long and carefully managed journey behind that simple bar of soap. It's a perfect example of how science quietly powers everyday life. If you enjoyed this deep dive into how soap is made, don't forget to like, subscribe, and comment on what manufacturing process you want to explore next.